aeroplanes. Let's do a very interesting sum now. Let's see the sum. It says an aeroplane leaves an airport and flies due north at a speed of 1000 km per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 km per hour. How far apart will the two planes be after 1.5 hours? Now, this is what the sum says. Let's understand this. Let's present this in a diagrammatic way. It says an aeroplane leaves an airport and flies due north at a speed of 1000 km per hour. So what we are saying is that we consider a point A and we say that suppose the aeroplane starts from this point A. It starts from point A and flies due north at the speed of 1000 km per hour. That means it is moving towards the north direction. That means it would be like this at a speed of 1000 km per hour. Right? Then it says at the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 km per hour. So suppose another aeroplane starts from the same point, right? From the same airport, from the same part. So from the same point we have taken A and it moves towards west, right? So it is moving towards west. Now the speed is more than as compared to the earlier one. So here the speed is 1200 km per hour. How far apart will the two planes be after 1.5 hours? So obviously after 1.5 hours flying, right, from A, that first aeroplane would have reached B and the second aeroplane would have reached C. So how far are they apart is nothing but that is BC. So that means we have to find the length of BC to get this. This is what the sum says. Is this much clear to everybody? Yes. Beautiful, right? Now let's understand here. So we need to present here what is AB, what is BC, what is AC, right? Let's write it down. So AB here represents the distance covered by the first aeroplane, right? That is what is AB representing. And the same way AC represents the distance covered by the second aeroplane, right? And now we know that in the figure, if you see, we have just mentioned that the speed of the first aeroplane is 1000 km per hour. So if the speed is 1000 km per hour, that means AB is nothing but it is the distance covered by the aeroplane in that 1.5 hours. So distance it covers in 1.5 hours, right? In that speed, that is 1000 km per hour. And we know that distance is nothing but it is speed into time. That is speed is 1000 into time is nothing but 1.5, which is nothing but we take it into proper fraction, it will become 3/2. So now we get the answer is nothing but when we do the cancellation and get it, we'll get it as 1500 km. That means the distance, the length of AB is nothing but 1500 km. We know that. The same way, can we find the length of AC, right? And why we did this is because we know that distance is equal to speed into time. Now, we want the length of AC. Let's find the length of AC. Now, for AC, we do the same thing there. The speed of the second aeroplane is equal to nothing but 1200 km. That is the thing given to us. That means we say that AC is equal to distance it covers in 1.5 hours. So we know that distance is equal to speed into time. That means we write it as 1200 into 3/2. That is equal to nothing but 1800 kilometers. So now we get the length of AC to be 1800 kilometers. So now we know the length of AC, we know the length of AB. So can we find the length of BC? Yes, we can find it. So let's find it out now. So now how do we find BC? But we find it by Pythagoras theorem. So now we apply Pythagoras theorem. We write in triangle BAC. In this triangle, we know that angle BAC is equal to 90 degree. So we write there for the BC square is equal to AB square plus AC square. The reason is nothing but by Pythagoras theorem. Now we have to just substitute the value. We know the value of BC? No, we keep it as it is. Do we know the value of AB? Yes. How much is that? 1500, right? Now that square plus AC square. Do we know the value of AC? Yes, we know the value of AC. That is nothing but 1800. So we take that value there and we substitute it. So it is 1800 square, right? Now we have to just solve it. It's a numerical calculation. So now we write BC square is equal to 1500 square. What is 15 square? It is 225 and 2 zeros. For that the square would be, we'll get 4 zeros there. That means it will be 225 and 4 zeros after that. Plus for 18, we take the square of 18. 18 is nothing but 324 and 4 zeros after that. So this is what we got, right? Now we add it, so we get BC square is equal to 549 and 4 zeros after that, right? So it is 54,90,000 which we got. But we want the length of BC, so BC is going to be taking square root on both sides. So we get BC is equal to square root of 549 and 4 zeros after that. Right, now how are you going to simplify that? Now 4 zeros can be written as 100 into 100, that we know. So only we have to factorize that 549. No. When we factorize that 549, it is nothing but it is 9 into 61, and 4 zeros, as I said, would be written as 100 into 100. Now it's very easy. So what is square root of 9? It would be 3. Square root of 61, we can't find it. We'll write it as it is, that is root of 61. And for that 100 into 100, the square root would be 100. That means we'll get 3 into 100 outside, which will be 300. So now we get BC is equal to, right? So that is what we got, 300, and root of 61 remains as it is. So we get BC is equal to 300 into root of 61 kilometer. That means now have we got the sum? Yes. So now we know that the two planes are 300 into root of 61 kilometer apart from each other, right? That is what we write. So distance between the two aeroplanes is equal to 300 into root of 61 kilometers. After that, 1.5 hours. Wasn't that easy? A very interesting sum, right?